Hello friends, welcome back to my YouTube channel Code with Dharamveer. In the previous video, we have talked about stack memory versus heap memory. Now this video is going to be a very important video because we are going to talk about the garbage collection in Java. It's a very important concept, so please don't miss this video. Watch the video till the end. Java basically automatically deletes the object from the memory, but sometimes it pauses your application, whole application to do it. Yes, it's right. It pauses your whole application sometimes to do the this type of activity as well. Okay, so your backend server may be stopped, your Spring Boot application may be stopped, your production system may be stopped, can literally stop a moment, right? Because of something called as a garbage collector. Your whole system can stop literally for a moment. This is due to because of the garbage collection in Java, right? The core problem is that everybody knows that if you want to create a new object in Java, you are going to create using the new keyword. If I created an object user, then the object is created, right? The memory is allocated for this object in the heap memory. Now imagine there might be thousands of objects maybe created in the heap memory. So what happens if the memory gets full? Now, who cleans this memory? In C++, C developer manually frees this memory. But in Java, JVM does it automatically. And that system is called as garbage collection. So what is a garbage collection? Garbage collection, or it's simply called as GC, is a process by which the JVM identifies the unused objects. It removes from the heap memory and reclaims the memory space for the new objects. So in simple terms, if we talk about garbage collection, deletes the object that are no longer reachable. So important word is here a reachable, because the JVM does not deletes randomly. So basically it's no JVM is not going to delete any object randomly. It deletes the object which are that are not exist anymore. Now let's understand how. So this is basically a JVM heap structure. You have different sections here. You have a young generation, in that you have Eden space, S0 survivor, S1 survivor, and the minor GC, that is minor garbage collection, happens here. The next section you have old generation, tenured generation. So long lived objects here. So promoted from survivor, right? So whichever the objects are promoted from survivor, they lived here. So this is a major or full GC uh, appears or happens here, right? Then you have another section as a Metaspace that stores the basically class metadata. So it stores class structures, method metadata, runtime constant pools, etc. So this is basically a JVM heap structure. It is very important to know. So JVM is, let's talk about the JVM heap structure. It is basically, I've already told you, it's divided into different sections. You have young generation, you have old generation, you have Metaspace for class metadata. So let's break down this. So if let's talk about the first, that is young generation. This is where the new objects are created. So young generation is a area where the new objects are created. It has Eden space. It has survivor space zero S0, survivor space S1. So most of objects which are young die here. So JVM optimizes this area for fast cleanup. So this basically this area is optimized for the fast cleanup. Now you have old generation. So old objects that survive from the multiple GC cycles are moved here. These are long living objects, and cleaning this area is really a heavier one, right? So Then you have a next area, that is Metaspace. So Metaspace basically stores a class level metadata. It's not a regular objects. Now here it's where it's become really interesting. Garbage collection is not a single process. There are different types in the garbage collection. Now let's look into those types. So those types are basically garbage collection are mainly, first one is a minor garbage collection, second is major garbage collection, third is full garbage collection. Now minor garbage collection happens in young generation and it's triggered when the hidden space is full up. It's fast, frequent, and efficient. Now, the major GC, that is happens in the old generation. It is lower and it's more expensive. It's very heavier as well. So next is full GC. Full garbage collection happens when it cleans the entire heap area. So it's basically it's cleaning the young area plus the old area. So this causes something critical, and that is basically called as stop the world. Now what is the stop the world? We are going to discuss about that one. So stop the world is the thing when GC runs, the application thread pause. Even everything stops temporarily. User might feel a delay here. This is why the garbage collection tuning is extremely important in production systems. Now let's understand how the JVM decides what to delete. JVM identifies the garbage on the basis of mark and sweep. So JVM uses a algorithm called as a mark and sweep algorithm. So step 1 is mark phase. JVM starts from something called as GC roots. So it starts with the GC roots. So GC roots includes local variables, static variables, active threads. It's mark all as a reachable object, right? Now the step 2 is a sweep phase. In this, objects that are not marked, that is basically unreachable, these are deleted. Now the step 3 is compact phase. Remaining objects are rearranged to avoid the fragmentation. That's how the memory is reclaimed. In simple theory, it's very simple and very simple. Now, when does the object becomes eligible for garbage collection? It's very important from interview point of view. An object becomes eligible when its reference is set to null, when the reference variables goes out of the scope, when the reference is reassigned, and island of isolation, object referencing each other but unreachable. This in these cases the garbage collection happens. So important is that the JVM decides when to run the garbage collector. It's not the programmer or it's not us. Now, there is one common myth regarding System.gc that if you call System.gc, it guarantees the garbage collection. No, it's not, because it's only a request to JVM. JVM may ignore this request. This is very common misconception with most of the programmers and most of the developers, right? So interviewers love this question, asking this question. So keep a note of that. So advanced, if you talk about the advanced insight, modern JVMs basically uses the collectors like G1GC, ZGC, Shinnon Doho GC. They reduces the pause times, right? Whatever the pause times you have when the GC runs. So basically these collectors are going to reduce the pause times and improve your performance. They are going to optimize memory fragmentations. So garbage collection is basically just not cleanup. It's a performance engineering, right? You have to fine tune your performance. So let's have a quick recap. So about the garbage collection. It frees unused heap memory. Works using mark and sweep algorithm. Has minor GC, major GC and full GC. It causes a stop of the world event. It's controlled by JVM, not by the developers. Now you understand how Java manages the memory internally. This is very important from interview point of view. So in the next video, I'll be showing something even more powerful. How memory leaks happens in Java, even though we have a garbage collection. Yes, memory leaks happen in Java. So if you are serious about mastering the Java internals, make sure you subscribe the channel. And here's a question for you. When does the object becomes eligible for garbage collection? Comment the answer. If this video helped you a little, please like the video, subscribe the video for Java series, press the bell icon so that you will be notified whenever the new video is uploaded. Till then, it's a happy coding from Code with Dharamveer. Thank you. Thanks for watching this video.